record again. We'll give that a try. Hello, Mr. Kasuka. We're back. Are you on audio? Talk to me, dude. Byman, talk to me.
Yes.
Okay. One person can hear me. Everybody probably can. Sorry about the glitch. I don't know what happened. I bounced the whole system, and I think we got it now. Um, Gee, sorry about that. We are now recording. The date is August 2nd, 2018. The time is now 6:18. We're a little late getting started due to a technical malfunction. Database indexing. Database indexing is like an index in the library. I'm going to be short and sweet with this. Let me push these down. So when the card catalogs were huge boxes of typed cards. Each index had one card for every book. There were three indexes. These took up an important thing is that these took up a significant piece of real estate. Here's a picture of a small one. That's a very small library, and then so the indexes require a great deal of storage space in the database. Complex data structure, and in the physical index, we had the red index. The red index was red cards, or they were red on the end anyway. So when you opened the box, you'd see the red, and this was the title. If I wanted to find the, this was, yes, the title. If I knew the title of the book, I could search the red index and it would be indexed by title. So if I wanted to find, I don't know, Moby Dick, story about the whaling voyage in about 1890, I think it was written. Look under that. If I looked under MOB, and I would find it alphabetized in those cards, and then that would take me directly to its position on the library shelf. Similarly, I could search by author. If I wanted to search by author, well, the author of Moby Dick was Herman Melville. Herman Melville wrote several other books. If I searched by author, I would find not only Moby Dick, which was a very famous book, but I would find Billy Budd and three, four, anyway, some number of years before the mast. Anyway, he wrote about sailing ships in about the turn of the century. And similarly, so that would be the yellow index, and all those cards would be yellow. The blue index was the subject, and I could find all the books about whales. So I would find, of course, Moby Dick, that's about whales. I would also find the, I don't know, end of a book of cetology. Cetology is the study of whales, and every other story about whales. I guess I would find Jonah and the whale in there from our Bible. Um, anyway, I would find everything about whales. So if I wanted to locate a book by title, I would search the title, go straight to the textbook in the shelving area. I know exactly where it was. I may easily locate a book by author or by subject questions. Talk to me. Let me know you're still hearing me. Talk to me, Byman.
Yes, I can hear you.
Okay, good. That's what I wanted to make sure. Uh, Example one. What if I wanted to find a book that contained 376 pages? I'd have to start at the beginning of the shelves and look at every book. Well, I'm sure that the number of pages is We have that. Why not build an index on the number of pages? Why not? Why not put the number of pages in this catalog in why not?
Too many.
Nobody cares. Nobody goes to the library and wants to read a book that has 376 pages. Nobody ever searches on that. Okay? That's a terrible index. Example 2. What about color of the cover? Let's say that there are only 5 colors. What did we say? 5. So let's see, what are the primary colors? Red, yellow, blue, I believe, and black and white. So the only colors that we can have on the cover are red, yellow, blue, black, white. There's only 5 of them. Would we build an index on the color? Who would want to read a red colored book? Nobody. But let's say they did. How many different colors would we have? 5. In that case, it's pretty likely there will be at least one book of any given color on every shelf. I'm not going to waste my time with an index. I'm going to go out to the shelf and grab the first red book I find. I'll find one in the first shelf I look. Similarly, if I wanted to find all of them, I'm going to have to hit every stinking shelf. Using an index is going to be a big waste of my time. It's actually going to slow me down. So I want something that is, let's see, do I have it? Using an index, if I'm going to have to find 20, 25% of the entire collection, it would be easier just to go through the shelves from start to finish. I'm going to come back to this one. Questions? Okay, does that make sense? I don't want to index even though nobody cares about the color of it, but even if they did, let's say people really wanted to read a red book, just go to the stacks and find one. That's a lot easier than searching the index. Why? Because the index, every shelf is going to have 3 or 4 of them on it. Sometimes books come with abstracts. 1-page synopsis. Should we index the abstract? Consider the title index. What information is on the card? Well, the title has to be. Therefore, we will have to reproduce the entire abstract on the index card. We don't want to do that. That's terrible use of our space. So if it's a big field, I don't want a big field for an index. I want something nice and simple and concise, an author's name, the title of the book, and 1 or 2 word topic. I don't want a big field. An example 4. Library system has to track materials being checked in and out. Should we index the field that records the checkout status of the book? Every time you check a book in and out, you have to update that field. We don't want to update the index. For example, you can bet there is an index built on your Social Security number. That's a given. That's really a done deal. Why? your social security number is only, everybody's searching on that. It's an important field. It only returns one record at most. It's a very low field. Second, it's not very, very big. So it meets all of our criteria. What if you went down to the Social Security Administration and told them, I'm tired of my Social Security number. I'd like to change it, please. What are they going to tell you? Anybody alive out there? Anybody awake today?
Yes.
So you go down and you want to change your Social Security number. What are they going to tell you?
Well, it's hard to do because
It's hard to do. They're going to tell you you're nuts. You can't do it. You can't change your Social Security number. Why? Because it's an index. Okay. In an index, we want values that do not change. You better believe your Social Security number is indexed. So if I'm going to build an index, what do I want? There are 4 things that I want. Let's go back and look through them. There are 4 things. That's example 1. Oh, okay. Well, example 1. I only want things that people care about. 376. Nobody cares about a book with 376 pages. I only want fields that people will search on frequently. What would these fields be? Primary key. You better believe it. Foreign keys. You better believe it. And others that make sense. And I can't tell that those are semantic. Okay, so primary key, yes, you better believe there is an index built on primary key. It's there, you don't have to do it. Foreign keys are almost always a good bet unless they fail some other test. What else? What else would you index under this that people really care about? Maybe phone number. Maybe address. I'm just guessing. I don't know. That depends on your application. Do you think the phone number is important? Will you in your database be searching on the phone number frequently? If so, it's a candidate for an index. Can you think of any others, perhaps?
How about the table titles themselves?
The what now?
The table, like how you have vendor table. How about the name of the table itself?
Well, the name of the table is a little above this. Down inside the table, let's pick something like the vendors table. Inside of the vendors table, what do you think we'd be searching on frequently?
Vendor ID.
Vendor ID, maybe. Maybe. Vendor ID is a primary key of the vendors table, though. It's already got a index built on it. So let's yes, I agree with you. Vendor ID, very definitely. Let me pull that up. Databases. Tables, vendors, columns. Okay, vendor ID is a primary key. Primary key already has one built on it. What else might we care about if you were just guessing that we might care about it? Maybe vendor name, do you think?
Yeah.
Maybe. Okay. Would that be important to us? It probably would. I would buy that. Address, probably not. City, state, zip code. Oh, what about phone? Might you search on the phone number frequently? You very well might. So if you said you're going to build an index on phone, I'm all over it. I'm saying that's fine. The account number, foreign keys, you frequently build indexes on them. Primary key is already there. You don't have to build one on primary keys. After that, I would choose, I believe, vendor name and vendor phone would be my choices. Do they meet the rest of our criteria? Now, here's the idea. It is not important that an index be unique. An index should be, I got to be careful here, sort of unique. An index should have, if I specify one phone number, how many vendors do you think I will return?
Just one.
One. Could I possibly have two? Yeah, I'm okay with that. If I have two, that's fine. What I don't want is to specify something like a city, and I say Fresno, and I get half of my database. Okay? So one or two or even three records is fine, but I want a very small number of records returned. That's why I say more or less, pretty much unique. Okay? So I don't want something like the color of the book. What would be a very bad index? If we were talking about the people who lived in Plano, Texas, where are we? Plano or Frisco? Let's say Plano. What about zip code? How many zip codes are in Plano, do you think? If you were guessing.
Oh, maybe 3, 4.
How many?
Maybe 3, 4. Maybe 2, 3.
Oh, I think there's more than 3 or 4. If I were guessing, I'd guess 15. I'm just guessing. I don't know. Don't have a clue. But nonetheless, if I specify the zip code, I'm going to get hundreds of people if I have every address in Plano and I specify the zip code. I'm going to get hundreds and maybe thousands of records. I don't want that in an index. I want to specify the phone number. Now, it's quite possible that I will have two people with the same phone number. That can happen. I don't care. That's not a problem. 2 is not a problem. 20,000 is a problem. Get my drift?
Yeah. The index could be 2 parts, right?
What's that?
Index could be 2 parts.
An index can definitely be 2 parts. I haven't gone there yet. But right now we're just talking about one. What would make a good index? And so phone number would make a good index because I have a very small number of records that would be returned. A zip code would really suck as an index because it's going to return thousands of records. Then I got to go search through all of those. Don't want that. So I want it to take me down to just 1 or 2 or maybe 3 records. I like 2 or 3. So first of all, somebody cares about it. It's important. Second, it gives me a small number of records. Third, the value for the field that's indexed should be small. Okay, I'm looking for something like your name, your phone number. I don't want a very big field in here. Why? Because I don't want to duplicate the darn thing each time. Does that make sense?
No.
No. Okay, the example here is a book has an abstract. An abstract is about a page of writing. I can easily put this into the database so that when you pull up the book, you can go read the book's abstract. Abstract tells you something about the book. It's kind of like a quickie review. It's about 1 page long or so. 500 to 1,000 words. That would be a terrible index. Why? Because it's long, and because I would have to reproduce that on each one of my index cards. Comments?
But why though? One abstract belongs to one book.
I agree with you. It meets all the others. People care about it, and it's going to return only 1 book. But the problem with it is that it is big. And it is going to take up a lot of room because I'm going to have to duplicate that very big value on each one of my entries. I don't like it if it's big.
Okay.
Okay. So there's one. I have to care about it. Well, I probably care about the abstract. It's probably important. I'd like to search on it. Number 2, if I specify the abstract, I'm only going to get probably 1 book. I should only get 1 back from it. But the problem with it is the darn thing is huge. How would you like to type that whole abstract to search for it? Duh. Okay. So, big. We don't want big ones. We want little ones. We want something like, oh, I don't know, your social security number, your name, your phone number, something that is down in the range of 15 to 20 characters max is what I like. If I have to go more, I can go more, but I don't like big ones, abstracts. Okay. Number 4, I want something that doesn't change. I want a social security number. Social security numbers don't change. I don't want, I don't ever want an indexed value to change. Let me think of an example that would change.
Telephone number could change.
What?
Telephone number.
A telephone number could change, but it doesn't change every day. The hotel that you happen to be staying in during your visit, or something. Let's see, I guess that would be one. Your hotel room could change easily. I'm trying to think of something else that could change. Your location would be a terrible index because you're always moving around, and so I would have to be constantly Updating that index. Oh, that would be terrible. Trying to think of something else. Your status for the morning. We don't want to build an index on something that is changing radically. I want to pick something that is a property that is not going to change. Now, your telephone number isn't, can it change? Yes, it can. Right? Is it possible for your telephone number to change? Yes, it's possible. How often does your telephone number change? Not real often. Therefore, your telephone number would still be okay. What I don't want to get for an index is something that is going to be in constant change. I use, for example, is the check-in, check-out status of a book. That's going to change all the time. Present, not present status of a student in class today. Terrible index. It changes. Okay, there are 4 of them there. 4 criteria. Let's go back over them again. What's the first one?
Don't index fields that are searched infrequent.
It has to matter to somebody. People are searching on this field. Oh, people search on books titles. People search on the authors. People search on the subject, but nobody ever searches on the number of pages. So author and title and subject are valid. Number of pages is not. Why? Nobody cares. Okay. So people in general have to care about it before we build an index. It's a hot field. We call it hot. Okay. Okay. Number 2, second one.
It should have distinctive value.
Okay. We say that the word for this that we use, it has a low cardinality. That means that if I give you a value, I say, I want the phone number 940-123-4567. How many records will I get back? I might get back 0. Might get back 1. Could I get back 2? Yeah, I might get back 2. Could I get back 3 that have the same phone number? That's possible. Could I get back 3? Will I get back 3,000? That ain't going to happen. Okay? And so that's what we want. We want something that's going to give us a low, if I specify a value, it's going to give me a very low number of records. That's a good index. And we say that the index has a low cardinality is the word we use. Now what I want you to say is, okay, zip code. If I specify the zip code 786-123, whatever, 78612, how, and that's a zip code, let's say in Frisco, how many addresses will I get back? I'll get back thousands. That is a bad index. If I specify one phone number, how many names will I get back? 1? Yeah. 2? Oh, maybe. 2 people can share a phone number. 3? I suppose 3 can share a phone number. I don't care if 4 or 5 do, but in general, I'm not going to get back 10% of my database. Does that make sense? It doesn't have to be unique. It just has to be low.
So does that mean it depends on the table?
Yes, it does. And building an index depends on your table. And this depends that you know something about your data. Because what if what if everybody in our database we knew had the same phone number? That we wouldn't build an index on the phone number.
Yeah.
Right? Everybody in our index lives in one city. We're not going to build an index on the city name. Although if they lived all over the United States, we might build an index on the city. It depends on your data. You have to know your data.
So creating an index or choosing a primary key, is it the same?
Very, very, very similar. Your primary key is going to qualify as an index. First place, it's important. Wouldn't you agree to that? Your primary key is important. If it isn't, why'd you choose it? The second one, the primary key is, let's see, primary key is going to only give you one record at most back when you specify it, so it meets that one definitely. You can't have two records with that primary key, so it definitely meets criterion 2. Criterion 3, the choice of a primary key. The last thing you want as a primary key is a very, very big field, like something that is hundreds of characters. Oh, no, 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 for the simple reason you're building an index. So you don't want something like an abstract or something that is going to be, you know, a person's resume. That's a terrible primary key. You want their social security number. You want something small. And that's the third criterion. You want something small for an index. I don't like to build indexes on anything that is larger than, I'm going to say, 32 characters or an integer. Sorry, who's talking? I hear somebody. Turn up my volume. Who's talking? Mr. Kozuka, is that you? I can't.
No, I didn't have any questions.
Okay, well, I see you there. Okay, so 1, it's important. 2, it gives me a small number of records returned. Number 3, it isn't big. It's just something that it's, I don't know, 15, 20 characters. Small. And finally, it doesn't change much. Can it change? Yes, it can. Every time it changes, it's a lot of work for your system. You don't want it to change because you don't want to be doing a lot of work all the time to update these indexes. There are 4 criteria for building an index. That's the thrust of this class tonight, those 4 criteria. Why would you build an index? When do you build an index? I'm going to ask you to build some. Okay. Go to the next one. Hey, this one's easy. Why you build an index? When you build an index? Argue in favor of, yes, I want an index, no, I don't. If you build an index and it fails any of those 4 conditions, you're going to be actually hurting the performance of your database. If I build an index and it's a good index, people care about it, people use it, Okay, it gives me just 1 or 2 records back when I specify it. It is a small value and it never changes. I'm going to improve the performance of my database. If any of those are false, I'm going to hurt my database. And number 1 and 2 are probably the most important. Okay, with that in mind, how do we create an index? There's nothing to it. Create index. Give it a name. On. Give it the table and the field. Wasn't that easy? The trick is, did you choose that field correctly? Creating the index is a piece of cake. There is nothing to it. The important thing is, does that field that you're indexing conform to those 4 criteria?
So in this example, demo 3 is the index.
The name of the index is demo index. Demo 3 is the field being indexed. Yes, I'm looking at it there. So the field being indexed is demo 3. So you looked at this table and you made some, let's see, demo 1 is a primary key. You're not going to index the prime. I'm going to talk about this. You're not going to index the primary key because there's already one on it. I'm going to talk about unique here in just a minute. So demo 3, what have we found out about that? We looked at it and we said, hey, people are searching on demo 3. People care about that value. That's somebody's phone number or something. People are looking for that. How do we know? I don't know, because we know our table. Right? There's nothing about the name that tells you that. But I'm saying that I'm assuming you have some information about this table, and you know that people are going to search on this field. Okay? You also know that if you specify a value there, you're going to get a very small number of return values. Okay? You also know by looking at it there that it's an integer. Integer is a good one for integer meets the qualification 4. Number 3. It's small. Okay, it's what? 4 bytes. I mean, that's nothing. And you also know that this field is not going to be constantly changing. Therefore, you choose to build an index on it. It meets your 4 criteria. And so create index, give it a name, on, table name, parentheses, field name. That's all there is to it. By the way, you can also drop the index.
Now, if there is the primary key.
Primary key.
And how am I going to use demo 3 then?
You don't have to worry about it. Once you create the, once you create the index, then that's all you need to do. The system will use it.
And how, so that we are not learning here.
Huh?
How their system is going to use it?
The system, you do not have to tell it to use the index. Once you create the index, the system will use it. This is why you do not want to create a bad index, because the system will use it even if it's a bad one. For example, if I created an index on the number of pages in a book, the system would use it. If I created an index on the zip code of a city, the system would use it, and it would actually slow down the performance of the table because it would be trying to look up the zip code by the index when it would be much faster simply to go to the table and search through it. If I created an index and the index field was too big, it was something that was pages of typing, then I would be wasting a lot of space. And finally, if I created an index that was changing all of the time, the system would be constantly trying to update that index, and it would be wasting the system resources. So if I create an index that conforms to that, it will help my performance. If I create a poor index, then it will not help and it will hurt. But this is the syntax of creating an index. Create index, give it a name, on, table name, field name. But it has to conform to those 4 criteria before I do that. So that's the semantics of it. The syntax of creating it is very, very easy.
I have a question.
Go ahead, please.
Why would we want to create an index in the first place? Is it because our database or our data is too huge?
If you think about it in a library, let's go back to my library idea. And the library has a whole bunch of books in it. And you go into the library and you're searching for a particular title. How do you find that title? Do you simply go to the stacks and start searching for it one by one?
No, well, that scenario, it makes sense to have an index because, you know, you have a huge volume. But what I'm saying is if I have a small database and it's functioning okay, creating an index would probably just hurt the database, like you say. So
it is true. If a table is very small and there are only 15 or 20 records in the table, it does not make any sense to create an index.
Gotcha.
If I only have 15 books in my library, I'm not going to build a card catalog on it. It would be a waste of my time. As I go to a larger library, and you come in and you're looking for a particular book title, then you go to the title index and you search for that title and you go straight to it on the shelves. Or you search for the author's name and you go straight to it on the shelves. Or you search for the subject, and that gives you 5 or 6 books, I would guess, and then you go straight to them.
So
I hear. Go ahead.
Okay, as far as me as an user, or when I create a database, or rather a table, so every time I create a table, I should be creating an index if the table is large, if it has many records.
You would create indexes when you had some knowledge of how the users would be working with these data. There is no rule that says if you create a table, then you will create 3 indexes. No. The rules are that you apply those. The word is a heuristic, a way of looking at it. So you look for fields that are not the primary key. I'm looking for fields that are important to people. What might that be? It might be a name. It might be a phone number. Perhaps it's an address. Perhaps it's I don't know, a Texas driver's license number. That would be a good one. But I'm going to index those things. Now, a foreign key is frequently indexed. A foreign key is frequently indexed. Why? A foreign key is the primary key of another table. That means it's probably important. That means that probably when you access it, you're not going to get a whole bloomp load of records back. It probably means it's small because it's a primary key. It probably means that it doesn't change much because it's a primary key. So when it is a foreign key, that is a very good bet for an index. May I say that again? When it is a foreign key in the table, what do I have here? Look at it. Look at this, the default account number. Default account number would be a good bet for an index, the only one that it would fail. There are very few there are very few account numbers. So if I were to go look at the account numbers, there aren't very many of them. So in that one, it would probably not work. So the question is it worth it? Don't know. Let's go look at the invoices table. Look at invoices in the columns. Okay. The invoice ID, primary key, that has an invoice on it already. What about the vendor ID? Create an index, yes, no?
Yes, it is.
Okay, now let's go through them. Is it important?
It's a foreign key.
It's a foreign key. That damn sure makes it important right there. If I specify one of them, will I very likely get only a few values returned? Yeah, probably. I mean, I'm not guaranteed. I don't know how many, but I'm not going to get the whole database. Is it small? Yeah, it's a primary key of another table. That means it's chosen to be small. And finally, is it changing? For primary keys aren't supposed to ever change. Okay, so this one is going to meet our requirements. Terms ID, maybe not. What else? How about invoice number? Would that make a good primary index?
Yeah.
Yeah, I think so. Is it important? Yes. Will I get a very small number of value? I'm only going to get one number back, probably. Could I have two? I suppose, but it's not the primary key. But I probably won't. Let's see. What invoice number? Is it small? It's a varchar 50. That's small enough. Will it change? I doubt it. Invoice date probably could be a value. What about invoice total?
Invoice.
That would probably stink as a.
I wouldn't do it.
I wouldn't do it because I don't know. It could change. Payment total, credit total, invoice due date. I don't know. Maybe. I mean, that's a call. So some of them, vendor ID definitely. Invoice number, I'd say, boy, that's a pretty sure bet. And the rest of them, not so much. definitely that foreign key. If it's a foreign key, that's 2 out of 3 going for it right there. Okay. Let me talk about a couple of other things. Unique. Where did I do unique?
Here, next line.
Next. Okay, unique is a constraint on a table. Okay, here it is right here. Constraint. Okay, I didn't talk about this one yet. Demo unique. Unique, demo 2. It's kind of like primary key. It's like primary key, but it does not require it to be not null. So if I require it to be unique, it can be null. We don't use unique a whole lot. If you declare it to, if you constrain it as not null and unique, it could be the primary key, because those are the constraints on the primary key. What else about it? So unique. If I say that something is unique, then that means that every time I put something into that table, I have to search the table to see if it's there. Primary key is unique, and the unique constraint is also unique, of course. If I have a value, let's see, demo, they're all int. If I want to put a 3 into demo 1 or demo 2, I have to search that whole table and see if 3 is already in that field. If it is, it fails. Now, that means I have to search it. Anytime I have to search it, we're going to build an index on it. So if it is constrained as a primary key or it is constrained as unique, excuse me, then it already has an index. Don't build one on it. Pues claro. Is that clear? If it is a primary key or it has a unique constraint, don't add an index to it. It is a waste of time. It already has an index.
Question.
Go.
So far, all the queries that we have used and created and all the tables we have used, we never had to know what is the index for each of the tables. So
yes.
As a user, we never have to know that, right?
That's true.
Index
the user does not specify the index. The user does not need to worry about what indexes are created.
How efficient is the database will depend on how good was the index.
The performance of the database will depend on how well the designer of the database created the indexes.
Okay.
Okay. The user of the database, the person, so we've stepped out of SQL now. Then SQL, you don't know anything about the data, the indexes. Indexes are created outside of your control, and they're created by the database administrator or the person who builds the database. Okay. Here, let's review what makes a good candidate. There they are. There's 4 of them. Frequently searched, almost unique, a small value, static data that don't change, and finally, not a primary key and not unique. If it meets these guidelines, then I would build an index on it. If it fails any of them, then that would be a disclaimer. Let me see what else we got. Okay, oh my goodness, this is what an index is. We're out of time. Oh, gee, Moni, I'm not going to ask you this on the test. You can look at it. This is what an index is. This thing is a monster. Pray that you never have to write. B-tree is a monstrously complicated data structure. And this is what it is in the memory of the computer. Oh, good golly, Ms. Molly, we're going to be here the rest of the night. I get into this thing. So I'm going to let you look at it. Well outside the scope of a sophomore class. It's a graduate class. This would be in, you'd program this in your graduate class. So I'm going to skip over this one. Indexing quiz. When do you index? Why do you index? I think the assignment is pretty easy. I give you this accounts payable. I'm calling it here third normal form. I skipped over some stuff to get here. And based on what we know, what would you use? What indexes would you create? Based on what we know, write the SQL code that would create the appropriate indexes. Create index. What index would you create? What about default account number?
There will be one index for each table.
I don't know that to be true. Would you index vendor name?
Yes.
Yes. Would you index vendor city?
No.
State? No.
No.
Zip code? No. Phone?
Maybe.
Probably.
Maybe. That's your call. I'm not going to argue with you. I would not index zip code. If you index zip code, I'm going to say no. If you index phone or don't index phone, that's your call. Invoice ID, no, because there is already one on it. It's a primary key. Vendor ID, definitely. Invoice number, yes. Terms ID, maybe. Get my drift?
Yeah.
Okay, it's a pretty easy assignment. We're out of time. Okay, I'm going to back off. Go ahead.
Sir, I have a question that's a little bit off the topic because I had emailed. I don't think you had a time to respond. It's about, say, because I'm in the health information technology program. Mm-hmm. So probably I'll be working in settings like a hospital and things like that. So if I was asked to back up a database,
right?
How do you back up a huge database like in a hospital?
Well, we haven't covered that exactly. You would use a person just coming into the system would not be asked to back up a database. That's the problem with it is that backing up the database opens up lots of security issues, meaning that if you're making a copy of the database, you're making a copy of all the patient's records. So where are you backing it up becomes an issue. It's not really difficult. It's just kind of a matter of you have a utility that does it, and you say, okay, back up, and you select the database. And then there are three kinds of backups you can do. There is what we call the full backup. It backs up everything. It's really huge. And then you have what we call the differential backup, and it backs up everything that has changed, only those things that have changed. And then you have an incremental backup that backs up only those things that have changed since the last differential backup. Okay, so if you need to restore the database, you restore from the last full backup, then you find the latest differential backup and install that one. Then you have to step through the incremental backup. So if you have 10 of those, you have to apply 10 different backups to it. But how you do it and which one of those you choose is you probably have a person that is designed to do that. Now, might you be asked to become that person? Yes, but in that case, the where you back it up and how that backup is secured.
Okay, so in the follow-up question to that would it be up to each organization's policy of where the backup is? Say, for instance, a hospital is burnt down, and you are asked to reestablish, patient records somewhere else, and
yes,
to just rebuild the hospital. So where you back it up to is, I guess, up to the plan of the hospital.
That is true. You probably back it up in off-site storage. Okay. But then how do you know that that won't get hit by a hurricane or something, so you probably have redundant backups. But the more redundant backups you have, the more vulnerable you are to them being stolen. So everything's a trade-off.
All right.
But a backup being stolen is if I wanted to steal your data, what I'm trying to get is one of those backups. Gotcha. How you do it is fairly simple. It's just kind of a matter of a few mouse clicks. But you only let very few people do that, because it takes the system down. Essentially, once you're backing it up, I really can't let everybody do it. So you usually do it in the middle of the night sometime when nobody's on the system. And finally, once you have the system and you have everybody thrown off of it, now it's fairly simple. Others. Okay, I'm going to wrap it up there.
Did you say last time that you'll have an announcement?
I'm going to allow unlimited time on. I'm going to put that in an announcement. I'm going to allow you to have unlimited time on the test 2.
Okay, that helps.
I'll put that in the. I'll modify the assignment to show that.
And it is due Sunday morning, you said?
Oh, let's see. Is that when I said? I don't think I said morning.
Saturday 11.
I usually put those at.
It's a Saturday 11:59.
Yeah, I think I said Saturday at essentially midnight, right?
Okay.
And then I allowed you to go a little bit over on it without cutting you off.
Okay, I guess that's where I got the Sunday morning.
I think it was midnight on both days. It usually defaults to midnight, and I don't recall ever changing it.
Okay.
Well, I guess I regret. I don't know why the microphone twitched out, but that has been known to happen. Okay?
Okay.
Okay, I'm going to end the recording now.
Okay, good night.
Good night. Good night.